Welcome back YouTube, this is Dynamo MK or Mozkasar here once again. And for today we'll be looking at vectors. For example, we have this vector right over here. So first of all, what exactly is a vector? A vector is any mathematical object that has both a direction and magnitude, regardless of how bad my handwriting is. So then first of all, we have one example of a vector over here, and we can clearly see that it starts from a certain point and it goes in a certain direction for a certain amount of distance. Given all that, how can we write this particular vector down? What do we write about the vector that tells us everything we need to know? First of all, since we're working in a two-dimensional grid, we need a vector with two components. These two components are obtained by starting from the first point. The first component counts how many units to the right or to the left we're going, and then the second unit counts how many units up or down we're going. In this case, we're going 4 units to the right and 2 units up. Note, if we're going left, then this would have to be a -4, and if we were going down, then this would have to be a -2. However, neither of those are true, so we have +4 and +2 for our vector. So what are the things that we can do with this vector? The first thing we can do is to multiply and divide this vector with real numbers. For example, we can multiply this times 3, and if we want to see what this vector equals, you multiply each individual component by 3. For example, 4 times 3, that's 12, comma, 2 times 3 is 6. And as you can imagine, this makes your vector exactly 3 times as long. So for example, we'll be going a total of 12 units to the right and 6 units up. Note that the direction is the exact same, and this does not ever change the direction except in one case, which we'll cover shortly. However, this number tells us how much longer it gets. You can also make it shorter too. For example, we can multiply this vector by a half, which would be the same as dividing this vector by 2. Let me just get rid of this. In this case, we do the exact same thing. 4 divided by 2, that's 2, and then 2 divided by 2, that's 1. This looks, as you would imagine, like the exact same vector, except it's exactly half as long. It has half of the magnitude as opposed to 3 times the magnitude. Also, one more thing to note. You can write a negative sign here, and this would translate to a -2, -1, and this would change the direction by making it go the exact opposite direction, so not too much of a drastic change. So in this particular case, instead of going 2 units to the right like this vector does, we're going 2 units to the left, because the negative sign says go the other direction, and the same exact direction was that -1. Instead of going up, we're going to go down. So then that's all you can do with real numbers. Past that, you're going to have to only operate with other vectors. More specifically, we're going to be able to add and subtract other vectors. So for example, we'll add this to another vector, say 3 comma minus 2. And so in order to figure this out, it's very simple. You take this first component, add it to the first component of this one, and you get 7 comma, and then minus 2 plus 2, that's 0. And in terms of what this looks like, here's that second vector. Again, 3 units to the right, 2 units down because of the negative sign. And then the sum vector starts at the same place the first vector starts, but then ends where the second one does. If you want to subtract vectors, you can do the exact same thing, except in this particular case, you would do 3 comma minus 2 plus minus 4 comma 2, which is, as we reviewed in the last part of this video, in the exact opposite direction. So in order to keep this video simple, we're going to cover one last thing that we can do with vectors, that being actually figuring out the magnitude. Figuring out the direction and multiplying this vector to other vectors is a bit of a complicated matter, and so we'll figure that out in the next one. In any case, if you remember my distance formula video, then this should look familiar. If not, you can watch it. I'll put an annotation somewhere on the screen and you can click that. First of all, you want to switch to the pen tool and not the vector tool. So square root of this squared plus this squared. So this would be 4 squared plus 2 squared. This can simply be written as 16 plus 4, which is equal to the square root of 20. And normally, you already know the exact magnitude or length of this vector over here. However, we can go a little fancier. If you want, you can rewrite this to be 4 times 5, which becomes the square root of 4 times the square root of 5. Since a lot of us already know that the square root of 4, being a perfect square, is very simply 2, we can rewrite this to be 2 root 5. And when it comes to the magnitude is usually shown as 2 flat bars right around the vector. So this basically means just the length or the magnitude of the vector without the direction. And in order to keep things simple, this will be everything for my first vector video. I will be covering vectors more later on. Just to keep things simple, this is just a little introduction to vectors. So I hope you found this video useful. If you did, please leave a like down below and do all that stuff that everyone tells their subscribers or whatever to do. But then if you didn't like this video or you felt as though this video could have been better, please let me know. My ears are open to what you guys have to say. In any case, this has been Dynamo MK or Moaz Kassar, and I hope to see you in the next video. Bye!